Hello, everyone. Let's talk about classes, chapter 9 out of your book. I'm Professor Benavides, and I want to start off by looking at the beginner's Python cheat sheet for classes. So we got a lot of topics, but let's just zero in on the first part of this chapter. If you'll notice, this cheat sheet talks to us about what classes are, shows us how to define a class, and how to instantiate a class. It also talks about attributes and methods. That will be understandable to you after I go over this, but I wanted to show you how these cheat sheets continue to be a great way of looking over what you're going to cover before you cover it, or for that matter, really after you cover something, coming back here and summarizing what you've studied. Okay, so what is object-oriented programming? Object-oriented programming is one of the most effective approaches to writing software. In object-oriented programming, you write classes that represent real-world things and situations, and you create objects based on these classes. Relationships between classes and objects. When you write a class, you define the general behavior that a whole category of objects can have. When you create individual objects from the class, each object is automatically equipped with the general behavior. You can then give each object whatever unique traits you desire. You'll be amazed how well real-world situations can be modeled with object-oriented programming. So what is instantiation? Making an object from a class is called instantiation, and you work with instances of a class. In this chapter, what are we going to cover? In this chapter, you're going to go ahead and write classes and create instances of those classes. You'll specify the kind of information that can be stored in instances, and you'll define actions that can be taken with these instances. You'll also write classes that extend the functionality of existing classes so that similar classes can share code efficiently. Also, you will store classes in modules and import classes written by other programmers into your program files. So why is it important? Why is it important to understand OOP? Well, understanding object-oriented programming will help you to see the world as a programmer does. It helps you to really know your code, not just what's happening line by line, but also the bigger concepts behind it. Knowing the logic behind classes will train you to think logically so you can write programs that effectively address almost any problem you encounter. Classes also make life easier for you and the other programmers you'll work with, as long as you'll work with as you take on increasingly complex challenges. When you and other programmers write code based on the same kind of logic, you'll be able to understand each other's work. Your programs will make sense to many collaborators, allowing everyone to accomplish more. So let's just go over some of the vocabulary here. Looking back over this, OOP, it's the major paradigm being used today by programmers to write code. And we have something called a class and something called an object. And most everybody says that a class is a blueprint for an object, and an object is an instance of a class, regardless of what programming language you're in. So we build a class first, and we build the class so that it has general behaviors, and we go ahead and put attributes in it, and we put behaviors in it as well, and then we create an instance of that class. So that's what an object is. That's when you create an individual object from the class, so that each object is automatically equipped with that general behavior. So what is instantiation? Remember, instantiation, other books talked about this as the cookie cutter analogy, is that you are stamping out an instance. It's kind of like having a cookie cutter and you have dough and you cut out a star and that's your cookie. So making an object from a class is called instantiation. You will work with instances of a class. So what do we put in this class? Two things, basically information and action. So the information will be what you store in it in terms of data, and the action will be the behaviors that would be exhibited by methods. So it's really important to understand object-oriented programming. It's used in very large programming endeavors. So it helps you to go ahead and organize larger problems into more manageable components. So that's why understanding object-oriented programming is really important, and it gives you a better understanding of your code. Okay, so let's start off by talking about how to create a class. So we start off by looking at our first example here, and what you see here is a simple class called dog. And so we see that on line 3, we start off with the keyword class and then dog, which starts with a capital D. So all classes must start with a capital letter, right? And inside of this class, we're going to go ahead and have a very special method called an init method. And the way you make it is you put 2 underscores, the word init, and then 2 underscores again. So this special method will run automatically when you create a new instance of the dog class, right? So inside other languages, if you studied other programming languages, some people call this idea the constructor because it's used to construct the object. And all of this will become more understandable when we talk about creating objects. So for right now, let's just go over the structure of a class. It's going to have an init method, and we're also going to see some special behaviors. We're going to have a behavior for this dog to sit and a behavior for this dog to roll over. The attributes or the data for this class will be name and age. It's as simple as that. So every init method takes self, which is a reference to the instance itself. And then we're going to go ahead, in this particular case, be working with age and name as attributes. So that's then used as an assignment statement. So what's coming, age is then assigned to self.name, and age is assigned to self.age. These become the instance variables, right? And that's done during instantiation. So hold on and we'll see what instantiation looks like in just a little while. But if you were to just run this right now, I mean, it doesn't do anything. It doesn't do anything because this is just the class. We haven't really instantiated an object off of it yet. So what can you do with a class? It's an important question that you should ask yourself. You could model almost anything using classes. Let's start by writing a simple class called dog that represents a dog. Not one dog in particular, but any dog. What do we know about most pets? Well, they all have a name and an age. So we also know that most dogs sit and roll over. Those 2 pieces of information, name and age, and those 2 behaviors, sit and roll over, will go into our dog class because they're common to most dogs. This class will tell Python how to make an object representing a dog. After our class is written, we'll use it to make individual instances, each of which represents one specific dog. So this is the dog class. And again, it starts off with the keyword class and then the name of the class, in this case, dog, which starts with a capital letter. and that line is then terminated with a colon, right? So each instance created from the dog class will store a name and an age, and will give each dog the ability to sit and roll. Here we define the class called dog. By convention, capitalized names refer to classes. In Python, there are no parentheses in the class definition because we're creating this class from scratch. So this is a class definition. Below the class name, we'll write the doc string, describing what this class does. So here we see underneath the on line 4 here, on my example, we have a doc string, and it simply says a simple attempt to model a dog. Okay, so let's drill down a little bit more on that init method. And a function that's part of a class is a method. We refer to it as a method. Okay, everything you learn about functions applies to methods as well. The only practical difference for now is the way we'll call the methods. The init method is a special method that Python runs automatically whenever we create a new instance based upon the dog class. This method has 2 leading underscores and 2 trailing underscores, a convention that helps prevent Python default method names from conflicting with your method names. So that's in case you were wondering why. So make sure to use 2 underscores on each side of the init method. If you use just 1 on each side, the method won't be called automatically when you use the class, which can result in errors that are difficult to identify. So how is the init method defined? So we're talking about this method right here, the init method. Okay. We define the init method to have 3 parameters in this particular instance. The self parameter is required in the method definition, and it must come first before the other parameters. It must be included in the definition because when Python calls this method later to create an instance of dog, the method call will automatically pass the self argument. Every method call associated with an instance automatically passes self, which is a reference to the instance itself. It gives the individual instance access to the attributes and methods in the class. When we make an instance of dog, Python will call the init method from the dog class. We'll pass dog a name and an age as arguments. Self is passed automatically, so we don't need to pass it. Whenever we want to make an instance from the dog class, we'll provide values for only the last 2 parameters, name and age. So what are attributes? The 2 variables defined in the init method each have the prefix self. Let's go ahead and take a look at this. See? On line 9 and line 10. Okay. The 2 variables defined in the init method each have the prefix self. Any variable prefix with self is available to every method in the class, and will also be able to access these variables through any instances created from the class. The line self.name gets name, which is on line 9, right? Takes the value associated with the parameter name and assigns it to variable name, which is then attached to the instance being created. So here we see name. Name is assigned to self.name, and that creates the instance of that variable. All right, so the same process happens with self.age, gets age. Variables that are accessible through instances like this are called attributes. So line 9 and line 10, we have attributes, and they're inside the init method. So what method does this dog class have? The dog class has 2 methods, sit and roll over. Because these methods don't need additional information to run, we just define them to have one parameter, self. The instances we create later will have access to these methods. In other words, they'll be able to sit and roll over. For now, sit and roll over don't do much. Okay? They simply print a message saying the dog is sitting or rolling over. But the concept can be extended to realistic situations. If this class were part of an actual computer game, these methods could contain code to make an animated dog sit and roll over. If this class was written to control a robot, these methods could direct movements that cause a robotic dog to sit and roll over. Okay, so let's take one last look at this before we go ahead and see how we create an instance of this class. So this is the class definition. The class definition in this case has an init method, and it has two methods. Special methods that in this case for the dog gives it the behavior of sitting and rolling over. Right now we're simply having putting in a print statement, but as was said, in this logic could easily be extended to include animations or control of the robot movement. Okay, so when we create an instance of this class, then the init method will be called automatically. All right. So let's look at the next example here where we actually create an instance of this class. So here's the same method, the same class from starts on line 3. I just collapsed it there. And on line 19 is where I create an instance of dog. In this case, I pass it Willie and 6, the age, and that becomes my dog. So I have one instance here. And then I go ahead and access the attribute name in a formatted string, and then I access the dog's or my underscore dog's age attribute and put that into a formatted string. Let me go ahead and run this real fast. And there we see the output down below. So this class is the same one that I explained just a little while ago. It contains the init method and two special methods. So right here on line 19, let's take one more look at this. When I create an instance of dog, I'm passing Willie and 6. So Willie goes into name, 6 goes into age. Willie is then assigned to self.name. Okay. And then age is assigned to self.age. So these become the instance variables. Right? Later on, we'll learn how we can go ahead and use these methods in just a minute. So for right now, we're zeroing in on the main idea right now is on line 19, how do you make an instance from a class? So what is an instance of a class? Think of a class as a set of instructions for how to make an instance. The class dog is a set of instructions that tells Python to make individual instances representing specific dogs. Let's make an instance representing a specific dog. See the print screen. So here we see that we tell Python to create a dog whose name is Willie and whose age is 6. When Python reads this line, it calls the init method in dog with the arguments Willie and 6. The init method creates an instance representing this particular dog and sets the name and age attributes using the values that we provide. So Python then returns an instance representing this dog. We assign that instance to the variable my underscore dog. So my underscore dog. Okay. The naming conventions is helpful here. We can usually assume that a capital name like dog refers to the class, or since it's got a capital letter at the beginning of that word, we can assume that it's a class. Lowercase names like my underscore dog refer to a single instance created from a class. So how can we go ahead and access the attributes? To access the attributes of an instance, you use the dot notation. We access the value of my underscore dog attribute name by writing my underscore dog dot name. Okay. Dot notation is useful, is used often in Python. The syntax demonstrates how Python finds an attribute's value. Here, Python looks at the instance mydog and then finds the attribute name associated with mydog. This is the same attribute referred to as self.name in the class dog. We use the same approach to work with the attribute age. The output is a summary of what we know about my underscore dog. So my dog's name is Willie and my dog is 6 years old is what we see here. And this is how we, go ahead and create the instance on line 19 and access the attributes with dot notation. Okay. Now, as far as calling methods is concerned, let's go to our next little example here. And after we create an instance from the class dog, we can use dot notation to call any method defined in dog. To call a method, give the name of the instance, in this case, my underscore dog, and the method you want to call, separated by a dot. When Python reads my underscore dot dot sit, it looks for the method sit in the class dog and runs that code. Python interprets the line my underscore dog dot roll underscore over in the same way. Now Willie does what we tell him to do. Okay, so let's look at this example. Let me run it. And Willie is now sitting and Willie rolled over. So why is it important to have appropriate descriptive names? This syntax is very useful when attributes and methods have been given appropriate descriptive names like name and age and sit and roll over. We can easily infer what a block of code, even one we've never seen before, is supposed to do. So let's look at creating multiple instances now on this next example. And basically, we're just talking about lines 19 and 20. So now I have one instance of dog called my dog, and I have another instance called your dog. And I can then go ahead and access the attributes by means of dot notation. So creating multiple instances, you could create as many of them. That's what we talked about. I threw in the idea of the cookie cutter, idea here is you can create as many cookies as you want with that little, template to cut out cookies from the dough. So you can create as many instances from a class as you need. Each dog is a separate instance with its own set of attributes. This has to sink in. Capable of the same set of actions. You can make as many instances from one class as you need, as long as you give each instance a unique variable name, or it occupies a unique spot in a list or a dictionary. Okay, so the dot notation on here. Very object-oriented in its style, and you'll see this in many languages. Here we see the name of the object, and then the dot, and then the method, sit. The reason why we're able to do this is because we instantiated the object on line 19. Otherwise, you wouldn't be able to do line 24. So this is an excellent little example. We've got a lot of things on the screen here. Typically, we're going to find that we create classes in a separate file, and then we create instances in a separate file to create modularity. But putting it all together here gives you an opportunity to see what's going on here. So that when I create my underscore dog on line 19, I pass Willie in 6. That creates one instance. Then I go ahead and create another instance called Lucy, and and Lucy's only 3 years old. That's your dog. Okay. So as you can see here, I access the attributes by means of the dot notation. So that would be object dot method. And I do that for my dog, and then I do it for your dog. And I call the sit method, okay, in each one of these. Let me go, did I run it? Let me make sure I'm running this. So I didn't run it. Okay, so my dog's name is Willie. My dog is 6 years old. And then I called my dog.sit. Willie is now sitting. Okay, so and then it goes on to say your dog's name is Lucy, your dog is 3 years old, and Lucy is now sitting. All right. So that's pretty much the the main ideas here. We have a class, and we create an instance of the class. So when we create the instance, we can create, or shall I say, we can create as many instances as we like from one class. So that gives us a lot of power, a lot of reuse, and that is why object-oriented programming is the major paradigm being used today to program. So the main ideas here so far is you create your class, it's the blueprint, then you instantiate an object, and when you instantiate the object, you can create as many of them as you want, and they'll all have their own separate instance variables, right? And when you're defining the class, it's important that you understand what the init method is and that it is called when you initialize or create the object. And the structure of the init method is it starts off with the keyword def, yes, and then a space and 2 underscores, the word init, and 2 trailing underscores. Remember, if you don't put in 2, if you just put in 1, things are not going to work out right. And also the init method always needs to pass self first. And self is a reference to the instance itself. Notice also that all methods in the class definition, okay, all methods in the class definition, right, you need to go ahead and have self in there as a parameter, okay, on there. Other things that were talked about here is I don't know whether you've been paying attention to this or not, but a lot of times you'll hear the words, camel case, Pascal case, and snake case. So snake case is when you type in something and it's one word, it's all lowercase, and then an underscore and then another word, right? Pascal case is when you have the capitalized letter of every word. And then camel case is when the first one is not capitalized, but every word after that is capitalized. I think I read somewhere in the book that he was calling something, I think it was either camel case or Pascal case, and it didn't seem, what I knew about it didn't seem like it was correct. So he doesn't define a lot of things, in this particular book, but it's a great book. There's so many things that he covers, so it's kind of okay, so to do that. So what I did now, as far as the try it yourselves, let's go ahead and take a quick look at the try it yourself examples. But I went ahead and I put those inside of, well, let's go ahead and do those using Visual Studio Code. Okay, so let me read the problem statement first. I can open up Visual Studio Code and we'll look at those. Okay, so this first one here is called restaurant. So this is exercise 9.1 restaurant. It says make a class called restaurant. The init method for restaurant should store two attributes, a restaurant name and a cuisine type. Make a method call called describe underscore restaurant that prints the two pieces of information, and a method called open restaurant that prints a message indicating that the restaurant is open. Make an instance called restaurant from your class. Print the two attributes individually and call them and then call both methods. So let's go ahead and take a quick look at this. I've got the class definition called restaurant. Here's my, subscreen on here, right? And it's always a good idea to go ahead and put that in all of your, right after every class for documentation. Remember, we do this for documentation purposes. He really doesn't show us how to print out the documentation, but I show you how to do that in a separate video. So for right now, just put in the doc string. You know that it's there for documentation purposes, and there's ways of printing out all the documentation for a particular project, right? So then we have the init method on line 4, and the init method takes 3 parameters in this particular case: self, name, and cuisine type. Okay. Then on line 6 and 7, what we have here are the instance variables. We go ahead and, or attributes, if you want to call it that way. So name.title is assigned to self.name, and cuisine type is assigned to cuisine or self.cuisine type on here, right? I'm wondering why they didn't capitalize the other one, but I mean, I would, for consistency purposes, do them both. But so the next method is called describe underscore restaurant, and this is the style that I was referring to as snake case, and that's what I've heard on the internet, how people describe that particular style. And this is the style of Python. Maybe they call it, I don't know why, but maybe they call it snake case because it's the style that's used a lot in Python programming, right? So just to remember those other words, if you were using, in some languages, the camel case, it'd be something like that, right? And then Pascal case, to me, would be that, right? Where you capitalize the first word of each one, right? So what you need to realize is that it's really important to be consistent. So if you're a Java programmer, you probably want to use camel case, right? But if you're a Python programmer, you want to use snake case, right? So that's a little comparison for people that come from different languages. So on line 9, I create a method called describe restaurant. Notice how we have to go ahead and create a parameter called self. And the init method has to have self first and then any other parameters following after that. So we describe the restaurant in a formatted string. We assign it to a variable and then print it. Same idea for the open restaurant method. We go ahead and create a formatted string and then print it. So here's where the magic happens, right there on line 19. On line 19, we go ahead and create an instance. Now we could create many instances, right? Like different kinds of restaurants, right? So we go ahead and create an instance and just call it restaurant. Of course, you could, like if it was your restaurant, you could say my underscore restaurant, or just like the example that we had before, your underscore restaurant, you know, and that would be the variable that would hold the instance. So, but in this particular case, on line 19, what's happening here is I'm creating an instance called restaurant, and we're passing the mean queen and pizza. So pizza, the mean queen goes in the name, pizza goes in the cuisine type. The instance variables are then created so that if we were to use these methods here, we would then be able to then access name and cuisine type. So we see that on line 20, where we do that by saying the object name, remember the dot notation idea, object name dot name and object name dot cuisine type. That's how we access the attributes online. So these are really great examples, because first he shows you how to do them, and then you're asked to build it, and it's an exact idea, exactly what we went over. We create the instance on line 19, 19 and 20, we access the attributes, and then on 23 and 24, we go ahead and call the methods. Now notice when you call the methods, sometimes, you know, before, remember we said that we should pass as many arguments as there are parameters. Well, it's different here. We don't pass self, but we do have to have the word self defined in the method definition inside of the class definition. All right. I'm going to go ahead and run this, but I'm going to run it. Let me run it with step into. So I'm going to put in a breakpoint right there on line 19. And then I'm going to come over here to run, and I'm going to go to start debugging and then Python file. And let's just go through this one little line at a time. I'm going to press F11. Notice, remember, line 19 is the first line that's going to get executed. Line 19 is the line that's going to get executed, but hasn't been executed yet. So when I press F11, look at what's going to happen. Let's see what's going to happen, okay? I press F11, and boom, flow of control comes all the way to the top. And you can see now that we're inside the init method. Why? Because remember, the init method gets called whenever you instantiate an object. So we're going to go ahead, we pass name, and the parameter is self, name, and cuisine. Remember, the self is the instance itself, right? But that's a requirement. We're passing name and cuisine type. So name is going to get assigned to self.name, which is the instance variable. And then cuisine type, right, which is, if you point to it, it's pizza. Pizza is then going to be assigned. I come back over here and go down to the next line, and it's going to say, it's going to end up printing the restaurant name. So notice how it says the mean queen, and then it's going to go ahead and print the cuisine type, pizza. And then now we're on line 23, and when I pressed F11, it goes to the definition, and it builds the formatted string, and it prints it, right? And then it comes back to the line in which it was called, and we go on to the next method call, which we're using dot operator here, which is object dot method. Notice how flow of control goes to the class definition, and inside the class definition, we're inside of open underscore restaurant. We build the formatted string, and then it's shown down below. Okay. And that's the end of this little demo. Let's go ahead and go on to the next one here. And this one is exercise 9.2, 3 restaurants. Is to start with your class from 9.1 and create 3 different instances from the class, and call describe underscore restaurant for each instance. Okay, so this should be a pretty easy to understand here. I've got my class definition on up here, and I'm just collapsing it so you can see what's going on. You all remember what it was. The class definition contains the doc string, the init method, and two special methods, right? And the init method always starts with self, which it's a parameter. These are the three parameters that it takes, right? And what it's going to do is it's going to initialize a restaurant. So it assigns name to self.name. These are the attribute variables, right? Or the instance variables, the attributes on here. So the magic happens here on line 19, line 22, and line 25. I create mean queen, Ludvigs, and Mango Thai. Those are the restaurants, right? I mean, you could have just called it restaurant 1, restaurant 2, restaurant 3, right? If you wanted to. But after you create the instance, or the object, if you would, you use the syntax of object.method, and it prints out the restaurant description. So let me go ahead and do a Control B. Oh, I didn't. Yeah, let me go ahead and click. Oh, Control B. What am I doing Control B for? That's in a different, that's in a different, what do you call it, language. That's for not language, but editors of line. Let me press the run on here. And I do like to click get rid of anything on there and then run so we can see it clean. So as you can see down here below, the output shows the Mean Queen serves wonderful pizza, Ludwig Bistro serves wonderful seafood, and Mango Thai serves wonderful Thai food, which could be like anything of the above, right? If you've ever been, on there. So when you instantiate each object, we're passing, two arguments. Those two arguments then, go into the special method, the init method, to create the instance variables. Those instance variables then can be referenced with these special methods to describe the restaurant and another one that opens the restaurant. Let's go to the next example on here. It says make a class called user, create two attributes called first underscore name and last underscore name, and then create several other attributes that are typically stored in a user profile. Make a method called the describe underscore user that prints a summary of the user's information. Make another method called greet underscore user that prints a personalized greeting to the user. Create several instances representing different users and call both methods for each. Okay, so let me go ahead and I like to get rid of the stuff so we can, unless, we can, before we run it, you can expand and collapse the class. So the class has an init method here. It's got to start off with self. We're passing first name, last name, username, email, and location. So as you can see here, we're doing the assignment statements to create the instance variables, and then we create special methods to describe the user, and then to greet the user. Now on line 23, this is where we create our instance, right? To create an instance, we've got the name of the object, gets, the name of the class, which is user, and then we must pass it as many arguments as we've got defined in the init method, which we would pass it first name, last name, username, email, and location. And then we'll call object.method for special methods to describe the user and to greet the user. So let me go ahead and go ahead and run this. And there we see Eric Mathis, and we see his username and location. Okay, excellent little example here. So this is the beginning, of this of our introduction to object-oriented programming. So You could say that we covered only two ideas of what is a class, what is an object, but we defined very carefully, what a class consists of. We learned about the init method, that it gets called when you instantiate an object, and hopefully you can see the flow of control of what happens when you create this object right here. Boom, it goes into the init method and it creates these instance variables. Many times it's called a init method because it's used to initialize your object to a particular state, right? And it's one of the ways to create an object. There are many other ways. This is a very typical and good way to start learning about how to create an object. The most important things here are understanding the structure of a class. So let's go ahead and go over it really fast. Starts off with the keyword class, the name of the class. The name of the class should start with the capital letters, right? If you have more than two words, then you would go ahead and capitalize the second word, right? So, I believe he called that, what did he call that? Camel case, but I call that Pascal case. So we have a small disagreement, as to what he's calling that style. So line 4, one of the other big thing here is the init method, right? And remember, it's 2 underscores, the word init, and then 2 more underscores, and you can't forget to put in the self keyword. And remember that self represents the current instance, and it is required. So self is a reference to the instance itself. And that self keyword is used to access the attributes in the init method as well as in the special methods by means of the dot operator. Okay. Then when we create our object and instantiate an instance and initialize it to a particular state, then we would use the syntax object dot member to go ahead and access either an attribute or to access a method or attribute, right? Many times you'll find that programmers will create the class in a separate file and then create the instances in a separate file. I don't see in this example here that we're doing Eric dot and then username. We're only calling 2 methods in this particular case. My reference to self would be for that particular instance. Okay, my friends. Well, that is that is our introduction to object-oriented programming. I hope that you have a clear understanding of the difference between a class and an object, what an init method is, and how a class is structured, that it's got an init method and special methods in there, and then the init method is used to initialize the object, and inside the init method we have our attributes, and then the special behaviors in the class are represented by methods. And once you create an instance, you can then access the attributes and the behaviors by means of object.member, which would mean object.attribute, right? Or object.method. All right. Thank you very much. See you in the next video.